Hello, people. This is Dr. Barnes, and you're watching Lectures with Dr. Barnes. Today, we're going to look at the three-phase balanced delta network using Matlab. That is, we're going to use Matlab to realize or verify the three-phase balanced delta network. So we open straight on to our Matlab and we go to Simulink. So in Simulink, we open blank model. So in blank model, we're going to go to library browser. All right. So when we have the library browser, first let's look for our elements. So the first elements we're going to look for is the three hyphen phase. So three-phase source, but we type it as three hyphen phase source. Okay, so let me just go to enter. Okay, I made a little bit mistake here. Instead of source, I wrote cost. So let me just change that one to source. All right, so now let's just enter. Okay, okay, let's just spell our source correctly. Okay, so we do that, and now let's just go to enter. All right, so now our three-phase source pops up for us. We just drag and then we drop it. Good. Now we're going to need an RLC load impedance. So let's just type RLC over here. Okay, and then let's just click on enter. So let's see the kind of RLC load impedance which is going to work for us. I think this would work for us. So let's just drop it. Okay, so we can just double click on it. A dialog box opens for us and we can make any kind of change that we want to make to our RLC load impedance. So I want an RL. So in that case, when I choose it, I get my RL. And then I can go to OK, and then it just does everything for me. All right. Now I want to be able to copy this, so Control C, and then paste it, Control V. All right. So that is cool. Now I want to be able to rotate this, so I can just right click on it. When I do, it opens up, and then I can select rotate and flip, and then clockwise. All right. So it just does it for me. Okay. So now I can just copy this, and then I can just paste it. Okay, right, good. So everything is just that cool. All right, now I can just connect my RL loads to form my delta network. So this is a delta network. Okay, if you have a problem with the theory, you can let me know, and then I can help you to handle it. All right. So now A will go to A. So now I'm connecting. This part is called the line or the source, and this part is called the phase part. So I'm just connecting the phase to the line or to the source to form my three-phase delta network. Okay, so here is a balanced delta network. Okay, so if you need explanation as to why we call it balanced delta, you can let me know and I can help you to deal with that. Okay, so and then C will come over here. All right, now that's cool. Okay, that's so cool. All right, now that's cool. Okay, so let me just adjust this a little bit. Okay, cool. All right. Okay, so now I'm going to need some instrument for me to be able to take the readings of my voltages. So let me come back here. I can write, let's say voltage. Is it voltage? Let me just write voltage measurement. Voltage measurement. Okay, is it measurement? Okay, let me just, okay, is it now? Okay, I think okay, I think I've not spelled this correctly. So let me just do it again. Control A. Okay, so it pops out for me. All right, so this is my voltage measurement. I'm going to use this one for the voltage measurement. Okay, cool. And then I'm going to need an RMS also. So let me just type over here, RMS. All right. Uh, is it? I think it's going to open up for me. Yeah. So I think I should have an RMS here. Let me just look at the one that I'm going to need. Which am I going to need? Wow, man. I don't know whether I have, if I have what I actually wanted. Okay, that's cool. If this method is not working out for us, we can use another method. So that's cool. Let's just drag this one down, and then when we do that, we will find sim skip. So let's just click on sim skip. So let's just click on sim skip. Okay, so when we have clicked on sim skip, let's choose electrical. So we choose electrical. When we have choose electrical, let's choose um, let's choose specialized power systems. So we choose specialized power systems, and then let's choose sensors and measurement. Okay, so that's cool. I think let's now look through this one. So and see if we can find our RMS. Okay, cool. Now we find our RMS. So let's just drag it and then drop it here. And then we're going to need a display. So let's just come here. Let's just type display over here. All right. So okay, that's cool. All right. So these are a number of displays. So let's just see the one that we're going to need. Basically, the one that we're going to need is a DSO. Okay. The digital oscilloscope. So this is what we're going to need. So let's just drag and then drop it. Okay, cool. That's cool. All right. So now let's just connect our components together. All right. It's just that easy. Okay. It's just, oh, okay. No. Your lines must always be thick lines. All right. Okay. So always make sure you do have that. All right. So now let's just connect this one here. Okay. So to A and then to B. Okay, so now according to the balanced delta network theory, uh, what it says is that the voltage at the source must be equal to the voltage at the phase. Okay, so basically the voltage that I have here is VAB. So now I'm gonna also check the voltage over here also. So I'm gonna need these equipments again. So I will just copy them. I'll just hold down Shift and then I'll highlight them with my mouse. Now I'll just go to Control C. Now they are all copied, and then I can just paste them. All right. It seems I have to extend my distance. All right. So I just make it bigger. Okay. Okay. So let me see. Okay. So I can just use the arrow keys to adjust it, and I can adjust this one also to any place I want. Okay. So now I can make this one come this way. Okay. And then I can make this one also to come this way. All right. So now that's cool. Now I think we almost ready to go. But wait a minute. This one is VAB. That means that I must also go for the VAB here. But what I have here is VCA. So let me just delete this one and then delete this one. Now let me just take this one over here. Okay. I can shift this one a little down. I can shift it a little down, yeah. And then I can bring this one a little down. All right, that's cool. Okay, now let's do the same thing here. Okay, so now I have VAB here and I have VAB here. According to the balanced delta network, the voltages here are supposed to be the same. So we're going to run our circuit and then we're going to see if we're going to achieve this one. Before we run our circuit, we need a power source for our network to be able to operate. So what we can do is let's just go back to our Simulink library browser. So let's just type power, okay? So power GUI, okay? So then let's go here. Okay, so power GUI pops out for us. Now we can just drag it and drop it. So let me just drop it somewhere here. And then let me enlarge my screen again. Good. Now we're good to go. Now let's go to run. So now let's run our circuit and see. Okay, our circuit is compiling and it's going to run very soon for us. Okay, so now we can see that our voltages are what? They are the same. Our voltages are what? Are the same. You can see that the VA on the line voltage is 1399 volts, and the VA on the phase is also 1399. That means that that means that the balanced delta network is verified, because the voltage on the line is the same thing as the voltage on the phase, or the voltage at the source is the same thing as the voltage at the what? At the phase. You can click on the line or the source and also make any kind of changes that you want. So let's say we want to change our voltage to, let's say, 400 volts, and then we just come and click what? Okay. Now let's run it again and see what we get. Again, we can see that our voltages are what? The same. We have what? 22.13 volts on the line, and we have 22.13 volts on the phase. Okay, that is the VA on the line is 22.13, and the VA on the phase is also 22.13. That is, they are the same. That is, the balanced delta network is verified. Okay, we can go on ahead to check for several other voltages. Okay, we can say that we want to be able to check for VAC. So this is what? VAC, right? This one is VAC, or yeah, VAC. And then we can also come here and then check for the same VAC. All right, so the first one was VAB. Now we want to check VAC. So this is VAC. All right, so this is what? VAC. Okay, so now let's run our network and see. All right, so you can see the voltages are again the same. That means our network is what? Is correct. It's being verified. So let's say so this is VAC. Okay, so now let's say VBC. Okay, so this is VBC. Now let me just. Okay, so this is what? VBC. Okay, all right, and then this one, in this case, this one has to change. Okay, in this case, this one has to come here like this. All right, and then this one also has to come here like this. Let me just adjust it a little bit. Okay, and then here, let's bring it a little bit like this. Oh, did I do something wrong? Okay, let's just undo it. All right, let me just delete this one, and then let me see. Oh, okay, okay. Now let me just check it. Okay, it can be here though. It doesn't really matter. No. Don't worry, it can be there also, but I just wanted to shift it to a position that will be so clear for you, all right? Okay, it can be here also. So this is also VBC. This is VBC, and this is also VBC. So our voltages here is also supposed to be the same according to the balanced delta network. So let's run our network. We see that it's all what? 21.39 volts and 21.39 volts. That means that our network is what? Verified. It's verified. for the balanced delta network, for the three-phase balanced delta network. That's the voltage at the source or the line must be the same as the voltage at the phase. Okay, so the voltage at the source here or the line here, the line voltage is the same thing as the phase voltage. We can also go on and then do measurement for our current, but you know that with the three-phase delta network, the currents are always different. Okay, so with respect to the current, we wouldn't expect it to be the same, but the voltages must be the same. So let's just go on and then do it for the current. So in that case, I'll just delete my voltmeter and then select current and select an ammeter. That is an instrument for measuring current. All right. So let me just go on and do this. All right. But we're still going to need our RMS, and then we're going to need our displays. So those ones, I will leave them. All right. So let's just do this. All right. So let me just, let me just shift this one here a little bit. Okay. So let's just go back to I'll just minimize it, go back to our library, and then let's type current. So I'll just type current, okay? So this is what? Current, isn't it? So current measurement appears here for me. Okay, good. So let me just drag it. Okay, so voltage is always across, but current, we measure it in series. So let's say this one is IA. So this current will be what? IA. So let me just bring this one here and then connect it. All right. So here, this one will come here like this. All right, good. Okay, and then this one will come here like this. Good. And then this one will go here like this. Good. All right. And then, so this is IA, and then IA, which current again here can I measure? Okay, so let me also measure the current here. Okay, this one is going to be IAB. Okay, so let me just straight ahead and do it. Okay, so let me just bring it here. Okay, okay, I can enlarge it. Okay, so now let me put this one here. Okay, and let me put this one also here. Okay, I think we're cool. Okay, I think it's cool. Okay, and let me bring this one here. All right, all right, all right, all right, all right, all right, all right. I think we are cool. Okay, I think we're cool. Let me just see something. Maybe I can adjust this. I can adjust this. I can adjust this also. Oh, I can adjust this. I can adjust this. I can adjust this. I can adjust this. And let me just use the arrow keys to shift them. Okay, so that it will be much more clearer for you. Cool. All right. Now let's in terms of the current, they are supposed to be different. Okay, the voltages are going to be the same at the phase side, and then at the line side or at the source side. That means that the voltage at the source is going to be the same as the voltage at the phase. But with respect to the current at the source and the current at the phase will always be different. So let's just go to run. Okay, so you can see that we have 35.55 amps at the source side or at the line side, and then the current at the phase side is what? 20.88. Okay, so you see that they are different because the current at the phase side and then the current at the source side are supposed to be different with respect to the balanced delta network. All right, so we can go on ahead and then do the current for different parts of it. So let's say I can just copy this, I can just copy this, I can just copy this, okay, and then just copy like this, okay, and then Control V, bring it down here, okay, just use my arrow keys to switch them, and then I can measure the current here also. Let me just copy this, so I can just copy it, all right, and then come and paste it over here. Okay, and then I can connect this to this. All right, connect this to this. Okay, let me just okay, so I can just okay, I can just connect this to this. All right, and then I can just connect this one this way. All right, so cool. So you see that I can take the measurement of the current at different positions at the same time. Now let me just go on and then do my my simulation. So now you can see that the current what raise, okay, but the current will always what be different, unlike what the voltages, which are the same at the source side and then the field side. So we will end this lecture over here. If you have any question here, you can just put it in the comments section. This has been Dr. Barnes. Make sure you follow me, you subscribe, and then we can have much more lovely discussions. Enjoy your time. Bye bye.